Hello student, now we will see the next chapter, the continuity. Now in this chapter, one thing is that you must know the definition of the continuity. Then what is its definition? The value of the function is equals to the limit of the function at that point. Now we will see the definition, what topics we are learning in this chapter. Continuity of a function at a point. Continuity of a function over an interval. Intermediate value theorem. Now we'll see the first definition of the continuity. A function f of x is said to be continuous at a point at x is equals to a if the following conditions are satisfied. Then what are the conditions? The first is limit x tends to a, f of x is equals to f of a, or that is limit x tends to a, f of x exists. And the second condition, that is the value of the function f of a is equals to the limit of the function at that point, that is x is equals to a. This is very important definition for the continuity. And also in this chapter they have taken the number of types of examples. The sequence of the examples is not, I think, correct, but I will try to explain in a very simple way. Now let us start. We'll start the exercise. Then the given function will be continuous at that point. Now we'll start the exercise. This is the big exercise. First, examine the continuity of first is f of x is equals to x cube plus 2x square minus x minus 2 at x is equals to minus 2. Means in this case we will find out the limit of the function and also the value of the function. That is what is meant by the value of the function. That is, we will substitute here x is equals to only 2 and find out the value. If both are equal, then we'll say that the given function is a continuous. Now see this. Limit x tends to 2 minus f of x is equals to x is replaced by minus 2 there only. That is, this is the thing. X is replaced by minus 2 and then find out the value. That is minus 8 plus 8 plus 2 minus 2. What is the limit of this function as x tends to minus 2 is equals to 0? This is number 1. Every time to show the continuity, you have to find out the limit of the function and then the value of the function. Now we'll find out the value of the function. Then how to find out the value? Now see this. That is f of x is equals to x cube minus 2x plus 2x square minus x minus 2. Only replace x by minus 2. And overall you are getting that the value of the function at x is equals to minus 2 is 0. Now the limit is also 0 and value is also 0. Therefore, by the definition of the continuity, the given function is continuous. Hence the given function is continuous at x is equals to minus 2. Second, f of x is equals to sine x for x is less than or equal to pi by 4 is equals to cos x for x is greater than pi by 4, and we want to check the continuity at x is equals to pi by 4. Then what to do here? That is, we will find out the limit. But in this case, we are checking at x is equals to pi by 4. That is when the function, that is x, value of the x is less than pi by 4 and greater than pi by 4. When it is less than pi by 4, then we treat it as the left hand side limit. And when it is a greater than pi by 4, then we treat as it is a right hand side limit. And also the value of the pi by 4 given function at x is equals to pi by 4. For that, here is less than or equal to. Therefore, for that we take, to find out the value of the function, we take here sine x. Now see this here. Limit x tends to pi by 4. Now this line is very important. That is a limit x tends to pi by 4. And here is a minus sign. This minus sign indicates that it is only the left hand side limit. It indicates the left hand side limit. That is, limit x tends to pi by 4 minus sign indicates that it is a left hand side limit. But when we find out the limit, we substitute not minus pi by 4, only the pi by 4. Also here limit x tends to pi by 4 plus. Plus means what? It is a right hand side limit. It is only the indication for the right hand side limit. And we substitute when x is equals to pi by 4. And this is the value of the function. Whenever we have given the interval, then we write in this way. To find out the value of the function, f of pi by 4 is equals to sine of pi by 4 is equals to 1 by root 2. Now next, for f of x less than or equal to pi by 4. When it is a less than pi by 4, then we treat it as the left hand side limit. That is the sine of pi by 4. And the value of the sine of pi by 4 is 1 by root 2. Left hand side limit is 1 by root 2. Now we'll find out the right hand side limit. Limit x tends to pi by 4 plus f of x. Limit x tends to pi by 4 of the sine x. Therefore, its value is 1 by root 2. And from 1 to 3, left hand side limit is equals to the right hand side limit is equals to the value of the function, and that is equals to 1 by root 2. And hence, the given function is a continuous at x is equals to pi by 4. Now the next, f of x is equals to x square minus 9 upon x minus 3 for x is not equals to 3 and equal to 8 for x is equals to 3. It means that here we have the value of the function is 8, which is given there. Now see this, limit x tends to 3, f of x is equals to f of 3. Now see this here, f of 3 is equals to 8. Value of the function is equals to the limit of the function, then the given function is a continuous. Now we'll see, this is the definition and they are not equal. Now I am writing here f of 3 is equals to 8. Now limit x tends to 3, x square minus 9 upon x minus 3. Then x minus 3 get cancelled. Therefore, we will take the limit that is equals to 6. This is the limit of the function. And we have given that the value of the function is 8 and both they are not equal. And hence, the given function is not continuous at x is equals to 3. Now next problem. Examine whether the function is continuous at the points indicated against them. The first is f of x is equals to x cube minus 2x plus 1. X is less than or equal to 2. F of x is equals to 3x minus 2 if x is greater than 2 at x is equals to 2. Now see this here, we want to find out its continuity. We want to discuss its continuity at x is equals to 2. Now if we see this, x is less than or equal to 2 means this function is applicable for only the left hand side limit and the value of the function. Now why I take the value of the function? Because here is a less than and the simultaneously here is a equal to sign is also here. Therefore, to find the value of the function, we take here x cube minus 2x plus 1. And next, f of x is equals to 3x minus 2 if x is greater than 2. That is, our point is 2. To the left hand side, we take this function, and to the right hand side means what? That is, x is greater than 2. We take here 3x minus 2. Now, first of all, we write it. Limit x tends to 2 plus means what? We are right hand side limit, left hand side limit, and the value of the function, that is the f of 2. Now first we find out the left hand side limit. At that time we take that function x cube minus 2x plus 1. Now to find out the limit of this function, replace only x by 2, that is a 2 cube minus 2 into 2 plus 1, 8 minus 4 plus 1, that is a 4 plus 4, 1, that is equals to 5. Therefore, limit x tends to 2 minus of f of x, that is equals to 5. And this is the first left hand side limit is 5. Now, limit x tends to 2 plus f of x is equals to limit x tends to 2 plus in bracket 3x minus 2. Now, in this case also, x is replaced by 2. Therefore, 3 into 2, that is 6 minus 2, that is equals to 4. Therefore, the right hand side limit is 4. Therefore, f of x is equals to x cube minus 2x plus 1. Now, the value of the function, that is equals to 5. This is the third. Value of the function is 5. Now, in this case, all are not equal. But one thing is that the value of the function and the right hand side limit, they are equal, but left hand side is not equal. All three are not equal, and that's why we say that the given function is discontinuous at x is equals to 2, or it is not continuous at x is equals to 2. Now the next, discuss the continuity of the function f of x is equals to mod of 2x minus 3 at x is equals to minus 3 by 2. Now first of all here, find out the value, that is x is replaced by minus 3 by 2, that is equals to modulus of minus 3 plus 3, and that is equals to 0. This is the value of the function at x is equals to minus 3 by 2. Now mod of f of x is equals to mod of 2x plus 3. If we draw this modulus sign, then we have f of x is equals to plus or minus 2x plus 3. That is a 2x plus 3 is a greater than 0. If we solve this, then how to solve this? Subtract on both sides by minus 3. Therefore, this plus 3 and minus 3 get cancelled. 2x is greater than minus 3. Therefore, x is greater than minus 3 by 2. Therefore, limit. Now the function can be written as like this. F of x is equals to 2x plus 3 if x is greater than minus 3 by 2. And suppose that is a 2x plus 3 is negative, means it is less than 0. Therefore, it is written as like this, negative, and we'll solve this. That is, subtract on both sides by minus 3. Therefore, 2x is less than minus 3, and that's why x is less than minus 3 by 2. How we get divide on both sides by 2? Now, see this here. F of x is equals to minus 2x plus 3 if x is less than minus 3 by 2. And that's why we have the functions f of x is equals to 2x plus 3 if x is greater than minus 3 by 2, and f of x is equals to minus 2x plus 3 if x is less than minus 3 by 2. Now in this case, we will find out the two limits. Once the left hand side limit, this x is less than minus 3 by 2, this will be the left hand side limit, and x is greater than minus 3 by 2, this will be the right hand side limit for the function. That is, we take here function as a 2x plus 3. म्हणजे जर समजा आपल्याला राईट हँड साइडचं लिमिट जर काढायचं असेल ऍट द पॉइंट minus 3 by 2, तेव्हा आपण फंक्शन काय घेणार, तर f of x is equals to 2x plus 3. And suppose that if you want to find out the left hand side limit, means x is less than minus 3 by 2, then we take the function minus in bracket 2x plus 3. Now first of all we find out the left hand side limit, and that's why we will take the function minus in bracket 2x plus 3. And find out the limit. Therefore, you will get the value limit of the function that is equals to 0. Again, you can see this. First of all, we will find out the left hand side limit. We are substituting the values. And that's why we get the left hand side limit as a 0. Limit extends to minus 3 by 2. This is the right hand side limit. And we take the function 2x plus 3. That is 2 to get cancelled. Minus 3 plus 3 overall, that is equals to 0. That is a minus 3 by 2 must be there. I forget to write there. Here must be the minus 3 by 2. F is a continuous at x is equals to minus 3 by 2. Question number 5. Test the continuity of the following functions at the point or interval indicated against them. Test the continuity. Now first is f of x is equals to in root of x minus 1 minus in bracket x minus 1 raised to 1 upon 3 upon x minus 3 for x is not equals to 2 and equal to 1 upon 5 for x is equals to 2 at x is equals to 2. That's we want to check the continuity. Now the value of the function f of 2 is equals to 1 upon 5. Limit x tends to 2. F of x is equals to limit x tends to 2 in root of x minus. in root of x minus 1 minus in bracket x minus 1 bracket raised to 1 upon 3 upon x minus 2. Now here we will substitute, that is, put x minus 1 is equals to 8. X minus 1 is equals to h. Every time we substitute like this, that is a whatever the limit tends to, जे काही लिमिट टेन्स टू असतं त्यावेळेस आपण तोच नंबर इथे जनरली घेत होतो. That is x is equals to h plus 2. But in this case, we cannot take that. Because we want to replace this thing, that is in root of x minus 1. Therefore, we here take the substitution x minus 1 is equals to 8 as x tends to 2. That is, substitute here x is equals to 2. That is a 2 minus 1. And that is equals to h. 2 minus 1 is 1. Therefore, h tends to 1. Limit x tends to 2, f of x is equals to limit h tends to 1 must be there. That is limit h tends to 1, a root of h minus cubic root of h upon h minus 1. Now here root of h means what? H raised to 1 upon 2. Cubic root of h means what? H raised to 1 upon 3 upon h minus 1. Now here this is of the form limit x tends to a, x raised to n minus a raised to n upon x minus a. And using that we can find out, that is the limit h tends to 1, h raised to 1 upon 2 minus 1 minus h raised to 1 upon 2 plus 1. We will take the minus sign common from these two terms. Therefore, limit h tends to 1. Now see this here, how I had written. That is h raised to 1 upon 2 minus 1 raised to 1 upon 2 minus, take the minus sign as common, h raised to 1 upon 3 minus 1, and divide these two quantities by h minus 1 and h minus 1. And then you will get the result is like this. This is important. By using the formula limit x tends to x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1. And that's why you will get 1 upon 2 minus 1 upon 3. If you make the cross multiplication, then you will get, that is a 1 upon 6. Therefore, this is to limit x tends to 2, f of x is equals to 1 upon 6. But what is the value of the function? The value of the function is 1 by 5, and that's why the given function is not continuous at x is equals to 2. That is, it is a discontinuous. Then you can see this. You can write down. Pause करून तुम्ही लिहू शकता. Therefore, limit x tends to 2. The value of the function is 1 by 5. Therefore, from 1 and 2, both are not equal, and that's why f is x is equals to 2. Now the next is third. F of x is equals to x cube minus 8 upon in root of x plus 2 minus in root of 3x minus 2 for x is not equals to 2 and equals to 2. That is, f of 2 is equals to minus 24. At x is equals to 2. Now we'll check the continuity at x is equals to 2. The value of the function is minus 24. Now our job is to find out the limit of the function. This is number 1. Limit x tends to 2. F of x is equals to limit x tends to 2. x cube minus 8 upon in root of x plus 2 minus 3x minus 2. Limit x tends to 2, x minus 2 into x square plus 2x plus 4 in root of x plus 2 minus in root of 3x minus 2. It's multiplied with its conjugate part, that is rationalizing factor, root of x plus 2 plus root of 3x minus 2 to the numerator and the denominator. That is limit x tends to 2, x minus 2x square plus 2x plus 4 into in root of x plus 2, 3x minus 2 upon x plus 2 minus in bracket 3x minus 2. Now evaluate this, that is limit x tends to 2, x minus 2x square plus 2x plus 4 in root of x plus 2 plus in root of 3x minus 2 upon x plus 2 minus 3x plus 2. If we evaluate this, x tends to 2 in bracket x minus 2x square plus 2x plus 4 into in root of x plus 2 plus in root of x minus 2 upon minus 2x plus 4. Limit x tends to 2, x minus 2 x square plus 2x plus 4 in root of x plus 2 in root of 3x minus 2 upon take minus 2 as a common, then in bracket you will get x minus 2. From the numerator and the denominator, x minus 2 will get cancelled. Limit x tends to 2, x square plus 2x plus 4 in root of x plus 2 in root of 3x minus 2 upon minus 2. Now take the limit, that is replace x by 2. That is a 2 square 2 into 2 plus 4 in root of 2 plus 2 in root of upon minus 2. Therefore 4 plus 4 plus 4. This is the value that we substitute here. Again you can see this. Now replace x by 2. You can pause and write now. Now the simplification, 4 plus 4 plus 4. In next bracket, root of 4 plus root of 6 minus 2, that is will be the 4 upon minus 2. And simplification, 12 in bracket 2 plus 2 upon minus 2. 12 into 4 upon minus 2. And that is equals to minus 24. This is the limit. Now limit x tends to 2, f of x is equals to minus 24. This is 2. Therefore from 1 and 2, limit x tends to 2, f of x is equals to limit that is equals to f of 2. Therefore f is a continuous at x is equals to 2. That is the value of the function is equals to the limit of the function. Now next, number 3. F of x is equals to 4x plus 1 for x is less than or equal to 8 upon 3. 59 minus 9x upon 3 for x is greater than 8 upon 3 at x is equals to 8 upon 3. Now in this case, that is the what's happening here, that is x is greater than, that is we take the right limit, and here is x is less than or equal to 8 upon 3. Therefore, now see this here. F of x is equals to 4x plus 1 to for x is less than or equal to 8 upon 3. To find out the value, here is a less than or equal to find out the value, that is x is equals to 8 upon 3. X is equals to 8 upon 3, substitute here. That is the f of 8 upon 3 is equals to 4 into 8 upon 3 plus 1. That is the 32 plus 1. That is the 4 into 8, which is 32 upon 3 plus 1. And if you simplify it, then you will get 35 upon 3. That is equals to 35 upon 3. Therefore, f of 8 upon 3 is equals to 35 upon 3. This is the value of the function at x is equals to 8 upon 3. Now we'll find out the left hand side limit, that is limit x tends to 8 upon 3 f of x. Limit x tends to 8 upon 3 4x plus 1. To find out the left hand side limit, it's clear that x is less than 8 upon 3. Now replace only here x is equals to 8 upon 3 and find out, that is you will get 35 upon 3. Therefore limit x tends to 8 upon 3, left hand side limit is a 35 upon 3. Now limit right hand side limit x tends to 8 upon 3 f of x is equals to limit x tends to 8 upon 3. 59 minus 9x upon 3. Replace x by 8 upon 3. That is a 59 minus 9 into 8 upon 3 upon 3. That is a 59 minus 24 upon 3. That is equals to 35 upon 3. And if you see this, from 1 and 2, 3, limit x tends to 8 upon 3 f of x is equal to limit x tends to 8 upon 3. Left hand side limit is equals to the right hand side limit is equals to 35 upon 3, and hence the given function is a continuous at x is equals to 8 upon 3. Now next, fourth one, f of x is equals to 27 minus 2x bracket is to 1 upon 3 minus 3 upon 9 minus 3 in bracket 243 plus 5x bracket is to 1 upon 5 for x is not equals to 0 equal to 2 at x is equals to 0. The value of the function at x is equals to 0 is 2. We want to find out the limit of the function. Now this is the important, very tough problem is there. Normal consideration is not there. You have to adjust the terms. Limit x tends to 0 f of x. Okay. Limit x tends to 0. That is a 27 minus 2x bracket is to 1 upon 3 minus 3. I forget to write down the minus 3. Now limit x tends to 0 f of x 27 minus 3. I forgot to write down. I'm writing here. Now see this here. 27 minus 2x bracket is to 1 upon 3 minus 3 upon 9 minus 3 in bracket 243 plus 5x bracket is to 1 upon 5. Divide numerator and the denominator by x. Here is also x. I have written there 3, but in place of 3 that must be x. Now see this here. Now there are the two limits, that is the L1 and the two separate limit, because this example is more complicated. Now limit, that is a L1 is equals to limit x tends to 0. 27 minus 2x bracket is to 1 upon 3 minus 3 whole divided by x. That is limit L1 is equals to limit x tends to 0. 27 minus 2x bracket is to 1 upon 3 minus 3 upon x. Now we will see how to solve this limit. That is multiplied numerator and the denominator by minus 2. Now we can see this here. Multiplied n and d by minus 2. Actually it is very. Now see this. This is the important step. That is minus 2 in bracket 27 minus 2x bracket raised to 1 upon 3 minus. What is meant by this 3? 3 means what? 27 raised to 1 upon 3. Again it is written as like this, 27 minus 2x, and this 27 is balanced by subtracting this minus 27. Therefore, now put 27 minus 2x is equals to some another different variable, that is equals to z. As x tends to 0, z tends to 27. Therefore, limit L1 z tends to 27 minus 2 in bracket z raised to 1 upon 3 minus 27 raised to 1 upon 3 upon z minus 27. Now we will find out the limit, that is a minus 2 into 1 upon 3 into 27 raised to 1 upon 3 minus 1 minus 2 upon 3 into 27 raised to minus 2 upon 3. Now see, this 27 can be written as 3 raised to 3 and whole bracket raised to minus 2 upon 3. This 3 get cancelled. We will get 2 minus 2 upon 3 into 3 raised to minus 3. That is, again it is simplified as this minus power will become plus, that is a minus 2 upon 3 raised to 3. This is the L1. Now we'll find out the L2. Limit x tends to 0. 9 minus 3 in bracket 43 plus 5x raised to 1 upon 5 upon x. Now again this can be written as, now first of all take, that is a 3 as a common, then we will get minus 3 as a common. Minus 3 as common, and it is written as, that is a 243 plus 5x bracket is to 1 upon 5 minus 3 upon x multiplied numerator and denominator by 5. If you multiply, that is a minus 3 into 5, that is a minus 15. Limit x tends to 0. 243 plus 5x bracket raised to 1 upon 5 minus 243 raised to 1 upon 5. Now the next 243 plus 5x minus 243. That is, we have the 5x only. We add and subtract 243. Now put t3 plus 5x is equals to w. Then as x tends to 0, w tends to 243. As x tends to 0, we to substitute x is equals to 0, w is equals to 43. Therefore, minus 15, limit x tends to 33. That is a w raised to 1 upon 5 minus 243 raised to 1 upon 5, and to the denominator w minus 243 minus 15, that is 1 by 5, 243 raised to 1 upon 5 minus 1. Now we simplify this. That is minus 15 upon 5, 243 raised to minus 4 upon 5. That is minus 3. 243 means what? 3 raised to 5. That 5 will get cancelled. Then you will get minus 3 into 3 raised to minus 4. That is minus 1 upon 3 raised to 3. सगळ्यात जास्त अवघड प्रॉब्लेम्स घेतलेले आहेत. Therefore, limit L is equals to capital L is equals to L1 upon L2. That is the value of the L1 is a minus 2 upon 3 raised to 3 and the value of L2 is minus 1 upon 3 raised to 3. Therefore, the answer is plus 2. See this again. Very tough problem. You have to see the adjustment. Therefore, from 1 and 3, that is the limit x tends to 0, f of x is equals to limit f of 0, and f is a continuous at x is equals to 0. Again, we can see this. This is the final definition. Therefore, from 1 and 3, limit x tends to 0, f of x is equals to f of 0 continuous at x is equals to 0. Fifth one, f of x is equals to x square plus 8x minus 20 upon now see the second problem. Next problem, f of x is equals to x square plus 8x minus 20 upon 2x square minus 9x. For x lies between 0 and 3 and x is not equals to 2, because if we substitute x is equals to 2, the denominator will be 0, and equal to 12 for x is equals to 2. And next is 2 minus 2x minus x square upon x minus 4 for x lies between 3 and 4 and equal to 3. Discuss the continuity at x is equals to 2. Now f of 2 is equals to 12. It is a given. That is number 1. Now limit x tends to 2. Limit of f of x, limit x tends to 2x square plus 8x minus 20 upon 2x square minus 9x plus 10. Limit x tends to 2. X plus 10. Now factorize it. X square plus 8x minus 20. X plus 10. X minus 2. Now factorize also the denominator. 2x square minus 5x minus 4x plus 10. That is limit x tends to 2x plus 10 in first bracket, second bracket, x minus 2, and to the denominator x common, 2x minus 5 minus 2 common, 2x minus 5. Therefore limit x tends to 2, x plus 10 in second bracket, x minus 2, and to the denominator x minus 2 and 2x minus 5. Now x minus 2 get cancelled from the numerator and the denominator. Therefore x plus 10 upon 2x minus 5, that is a 2 plus 10, 2 into 2 minus 5, that is a 12 upon 4 minus 5, that is equals to 12 upon minus 1, that is equals to minus 12. This is number 2. Therefore from 1 and 2, limit x tends to 2, f of x is not equals to f 2, and hence the given function is not continuous. It is a discontinuous at x is equals to 2. Now next is number 6, question number 6. Identify the discontinuities for the following functions as either a jump or removable discontinuity. Now, one thing. Now, first of all, what is meant by the jump continuity? That is the when the limit exists, left hand side limit exists, right hand side limit exists, and both are not equal, then it is called the jump continuity. Jump discontinuity. And removable discontinuity means what? The limit exists, but whatever that limit exists, it is not equal to the value of the function. Now we'll see in these problems. F of x is equals to x square minus 10x plus 21 upon x minus 7. Now we'll see here. This is the rational function, that is a p of x upon q of x. It is a continuous for all x belongs to set of real number except x is equals to 7. If you substitute x is equals to 7, then denominator will become 0. Therefore, limit x tends to 7, f of x is equals to limit x tends to 7 x square minus 10x plus 21 upon x minus 7. And if we evaluate this, then you will get limit x tends to 7, x minus 7 get cancelled. Limit x tends to 7, x minus 2, that is 7 minus 3 is equals to 4. Therefore, limit x tends to 7, f of x is equals to, that is exists. The value of the limit is equals to 4. And f of 7 is equals to 4. If we define f of 7 is equals to 4, then function will be continuous for all x belongs to set of real number. The discontinuity is removable. These are the theoretical questions. The f of x is equals to x square plus 3x minus 2 for x is less than or equal to 4, and f of x is equals to 5x plus 3 for x is greater than 4. Now x is less than 4, then it is a left hand side limit. We also have the value of the function. Now see this here, left hand side limit, x square plus 3x minus 2, substitute it, you will get 26. This is the left hand side limit. Limit x tends to 4 plus f of x is equals to limit x tends to 4 plus, that is a 5x plus 3. Substitute here 20 plus 3, that is a 23. Limit x tends to 4. This is the right hand side limit. Now what's happening here? Limit x tends to 4, that is left hand side limit is not equals to the right hand side limit. Now in this case, the discontinuity is irremovable. When we say that the given function is a continuous, the given function is said to be continuous when left hand side limit is equals to the right hand side limit. But originally our limit is not existing here. Therefore there is no the question of the continuity. म्हणजे पूर्वी असं होतं, म्हणजे असं आपण असं म्हणू शकतो की जर लिमिटच एक्झिस्ट नाही तर कंटिन्युटीचा प्रश्नच नाही. देअरफॉर द डिसकंटिन्युटी इज इरिमूवेबल. both exist but both are different. That is x tends to a plus f of x is not equals to limit x tends to a minus, that is the left hand side limit. Therefore f of x has jump discontinuity at x is equals to 4. F of x is equals to x square minus 3x minus 2 for x is less than minus 3 and is equals to 3 plus 8x for x is greater than minus 3. Now find out here again the left hand side limit and right hand side limit. Put x is equals to minus 3. That is a 9 plus 9, that is 16. Now the right hand side limit. That is equals to minus 21. Therefore again the left hand side limit is not equals to the right hand side limit. This is the new word introduced in this textbook. The limit of the function does not exist. Therefore f of x has a jump discontinuity at x is equals to minus 3. Now the next problem is f of x is equals to 4 plus sin x for x is less than pi. F of x is equals to 3 minus cos x for x is greater than pi. Therefore we find out the left hand side limit. Now here is a x is less than pi, therefore here we will take the left hand side limit. Limit x tends to pi, 4 plus sin x, and the sine of pi is 0, therefore the left hand side limit is 4. This is number 1. Limit x tends to pi, that is the right hand side limit, 3 minus cos x, and the cos of pi is minus 1, 3 minus in bracket minus 1, 3 plus 1, that is equals to 4. That is limit x tends to pi plus f of x. This is number 2. Now from 1 and 2, limit x tends to pi plus, that is the right hand side limit is equals to the left hand side limit, and hence the limit exists and equals to 4. If we define f of pi is equals to 4, then the given function will be the continuous at x is equals to pi. The discontinuity is removable here. If we define f of pi is equals to 4. Now the question number 7. Show that the following functions have continuous to the point where f of x is not defined. Also find the extension. That is show that the following functions have the continuous to the point where the f of x is not defined. Also find the extension. Now we'll see the problems. F of x is equals to 1 minus cos 2x upon sin x for x is not equals to 0. That is we want to define for, we'll solve this limit as x tends to 0. We have not given the value of the function. Therefore, first of all, we solve this limit. Now, one thing is that here is to solve this limit x tends to 0 f of x, limit x tends to 0, 1 minus cos 2x upon sin x. Now, what is the 1 minus cos 2x? That is a direct formula. That is a 2 sin square 2x upon 2. Therefore, you will get 2 sin square x, and that is a 2 sin square x 2x upon 2. Therefore, you will get 2 sin square x tends to 0 upon sin x. Sin x it cancel. That limit x tends to 0, 2 sin x. As x tends to 0, sine of 0 is 0. That is a 2 into 0 is 0. Now, if we define f of 0 is equals to 0, then f will be the continuous. म्हणजे या सर्व प्रॉब्लेम्स मध्ये आपल्याला एक्सटेन्शन द्यायचं आहे. आणि एक्सटेन्शन कसं आहे की त्यांच्या व्हॅल्यूज काय असणार आहे या टाइपचे क्वेश्चन्स आहेत. क्वेश्चन्स थोडी टफ आहेत, परंतु यू हॅव टू डू द प्रॅक्टिस. दॅट इज continuous extension that is equals to 0, f of 0 is equals to 0, and we can write it like this: f of x is equals to 1 minus cos 2x upon sin x for x is not equals to 0, and f of 0 is equals to 0 at x is equals to 0. Second, f of x is equals to 3 sin square x plus 2 cos x. म्हणून प्रत्येक प्रॉब्लेम हे वेगवेगळ्या प्रकारचे आहेत. इथे एक्सटेन्शन सांगायचं म्हणजे काय की इथे आपण लिमिट फाइंड आउट करणार आहोत, आणि लिमिट बरोबर काय दिलेली असते, आपल्याला व्हॅल्यू दिली असतील त्या फंक्शनची, मग त्याचं ते एक्सटेन्शन असणार आहे. म्हणून बघा इथे f of x is equals to 3 sin square x plus 2 cos x in bracket 1 minus cos 2x upon 2 in bracket 1 minus cos square x. Means in this case we'll first of all find out the limit of the given function. Limit x tends to 0, f of x is equals to limit x tends to 0, 3 sin square x plus 2 cos x in bracket 1 minus cos of 2x upon 2 in bracket 1 minus cos square x. आणि मग हे लिमिट सॉल्व करणार आपण रेग्युलर. दॅट इज 1 minus cos 2x. here we will apply the formula. that is a 2 sin square 2x upon 2 1 minus cos square x म्हणजे काय तर sin square x या प्रकारे. that is a 3 sin square x plus 2 cos x into 2 sin square 2x upon 2. That is we are applying the formula. 2 into 1 minus cos square x means what? Sin square x. Therefore, limit x tends to 0. 3 sin square x plus 4 cos x into sin square x upon sin square x. Now, from the numerator and the denominator, we will take sin square x as a common. Therefore, 3 plus 4 cos of x upon 2 sin square x. Now, sin square x get cancelled. Limit x tends to 0. 3 plus 4 cos x upon 2. Now, as x tends to 0, cos of 0 is 1. Therefore, 3 plus 4 is a 7. 7 upon 2. And therefore, 7 upon 2 will be the extension. म्हणजे extension म्हणजे काय की त्याची व्हॅल्यू आपल्याला घ्यावी लागणार आहे. That is a cos of 0, 1 upon 2. That is equals to 7 upon 2. Therefore, now we will define the function. Limit x tends to 0, f of x is equals to 7 upon 2. मग हे त्याचं लिमिट आलं. Now what is a f will be continuous at x is equals to 0. Now what will the continuous extension? Continuous extension is x 7 upon 2. That is f of 0 is equals to 7 upon 2. कारण की प्रत्येक लिमिटचा कंटिन्युटीचा हा प्रॉब्लेम कसा असतो, ती फंक्शन दिलेलं असतं आणि त्याखाली त्याची व्हॅल्यू पण दिलेली असते. आणि जी काही व्हॅल्यू दिलेली असते दॅट इज कॉल्ड द एक्सटेन्शन. for x is not equals to 0 and the f of 0 is equals to 7 upon 2. This is the extension. At x is equals to 0. Now next, third one. That is f of x is equals to x square minus 1 upon x cube plus 1 for x is not equals to minus 1. That is, first we will find the limit as x tends to minus 1. Limit x tends to minus 1, f of x is equals to limit x tends to minus 1, x square minus 1 upon x cube plus 1. Now to the numerator, we have the factors x minus 1, x plus 1 upon x plus 1 in bracket x square plus x square minus x plus 1. X plus 1 get cancelled. Now substitute the values. Therefore, you will get minus 2 upon 3. Now if we define f of minus 1 is equals to minus 2 upon 3, then f will be continuous. Therefore, f of x is equals to x square minus 1 upon x cube plus 1 for x is not equals to minus 1, and f of minus 1 is equals to minus 2 upon 3 for x is equals to minus 1. यापूर्वीच्या आधीच्या टेक्स्टमध्ये या प्रकारची प्रॉब्लेम्स नव्हती, परंतु त्यांनी याच प्रकारच्या आधीच एक्सटेन्शन वगैरे हे शिकवायचा प्रयत्न केला होता. पण माझ्या माहितीनुसार तुम्हाला फक्त दोनच गोष्टी पाहिजे होता. टेस्ट whether the given function is a continuous or not continuous. This was important, and after the perfection, then you can find out their extension. Now next is question number 8. Discuss the continuity of the function at the point indicated against them. अतिशय पुढचा एकदम फेमस प्रॉब्लेम आहे. That is, f of x is equals to root 3 minus tan x upon pi minus 3x, and that is equals to 3 by 4 for x is not equals to pi upon 3 for x is equals to pi by 3. It means that we have to check the continuity at x is equals to pi by 3. या टाइपचे प्रॉब्लेम्स तुम्हाला फक्त पाहिजे होती, कारण की सुरुवातीला तुम्हाला कंटिन्यूटीचा कन्सेप्ट जास्त चांगला समजला पाहिजे होता, परंतु ठीक आहे. That taken the extension. Now what is this? F of pi by 3 is equals to 3 by 4. Number 1. Now we'll find out the limit here. Limit x tends to pi by 3. F of x is equals to limit x tends to pi by 3. Root 3 minus tan x upon pi minus 3x. Now put x is equals to pi by 3 plus h. As x tends to pi by 3, h tends to 0. Root 3 minus tan x. The value of root 3 minus tan x is equals to root 3 minus tan of pi by 3 plus h. And now evaluate this. Tan of a plus b, tan a plus tan b upon 1 minus tan a into tan b. And after the evaluation, tan of pi by 3 is a root 3. This is the evaluation. Now see this here. After multiplication, we will get this is the simplification. Now root 3 into 1, that is a root 3. Root 3 into root 3, 3 into tan h minus root 3 minus tan h. This is numerator simplification. Now see the denominator. plus root 3 minus root 3 get cancelled. That is a minus 3 tan h minus tan h minus plus root 3 minus root 3 also get cancelled. Then you will get minus 4 tan of h 1 minus root 3 tan h. This is important. That is, first of all we find the value of root 3 minus tan of x. That is, next is pi minus 3x. We'll again separately find out the value. Its value is pi minus x is equals to minus 3h. Now limit x tends to pi by 3 must be there. I want to change here. This is not 0. It's a pi by 3. You can understand this. Not x tends to 0. It is a pi by 3. Now see this. That is, limit h tends to 0 minus 4 tan h upon 1 minus root 3 tan h upon minus 3h. Now this simplification is again important. That is a minus 4 tan h upon minus 3h in bracket 1 minus root 3 tan h. Again I am repeating here. This is the x tends to pi by 3. Now next step is now see this here. That is a, then I will repeat here in small amount. Minus next is, this is important. Now this is the tan of h upon h. The value of this limit will be the 1 minus 4 upon minus 3, that will be the 4 upon 3. And for this limit 1 minus root 3 tan h will divide and multiplied by h. Now the value of this limit will be the overall then 0. Now see this again here. That is, limit h tends to 0, 4 upon 3 tan h upon h into 1 minus, this is important. Now again you can see this. I will be repeating this. 4 upon 3 tan of h upon h. Important है tan of h. Now next step is also 4 upon 3 tan h upon h. हा जो h आहे तर त्यामुळे ते ओव्हरऑल सगळं लिमिट इथलं काय होतं तर 0 होतं. Therefore 4 upon 3 is 0 and overall you will get the limit is tends to pi by 3 f of x is equals to 4 upon 3. This is number 2. Therefore from 1 and 2 x tends to pi by 3 f of x is not equals to f of pi by 3 and therefore f is a discontinuous at x is equals to pi by 3. Now next is now the next example, f of x is equals to e raised to 1 upon x minus 1 upon e raised to 1 upon x plus 1 for x is not equals to 0 and equals to 1 for x is equals to 0 at x is equals to 0. That is, we will check it continuity at x is equals to 0. This problem is different type of the problems. You have to remember this problem. म्हणजे काही असे प्रॉब्लेम्स असतात की ते बघताच क्षणी आपल्याला जर त्याच्या स्टेप्स आठवल्यात तर ठीक आहे. अदरवाइज यू हॅव टू रिपीट दिस प्रॉब्लेम number of the times and you have to remember What is the technique to solve this problem? Now see this here. F of 0 is equals to 1. This is the value of the function at x is equals to 0. Now we'll take the left hand side limit, that is limit x tends to 0 e raised to 1 upon x minus 1 upon e raised to 1 upon x plus 1, and we substitute here, that is the x is equals to 0 minus h, and that's why x is equals to 0 minus h, as x tends to 0 h also tends to 0 to the numerator and the denominator. हा वेगळ्या प्रकारचा प्रश्न आहे. Limit h tends to 0 e raised to minus 1 upon h minus 1 upon e raised to minus 1 upon h minus 1. Now see this again here. Now the power of e is a minus 1 upon h, it will become plus, that is 1 upon e raised to 1 upon h minus 1, and to the denominator is also 1 upon e raised to 1 upon h minus 1. Now as h tends to 0, that is 1 upon 0, 1 upon e raised to 1 upon 0, and 1 upon 0 means what? It is infinity, and e raised to infinity, then it will be the very big quantity, that is a 1 upon very big number, that is it will become 0, and that's why you will get minus 1 here. See this again here. Now I will do here the minus sign to the denominator by mistake and taking it as a plus, and that's why that is 1 upon e raised to infinity. The meaning of this is that 1 upon very big quantity, that this will become 0, and again 1 upon very big quantity, this will again become 0. That is, in the numerator you will get minus 1 and denominator you will get plus 1. Minus 1 upon plus 1, and overall you will get minus 1. This is number 2. Therefore limit x tends to, that is the left hand side limit, is not equals to the f of 0. That is, when we take the left hand side limit is equals to the right hand side limit is equals to the value of the function. All three must be equal, and here we are saying here that the limit x tends to left hand side limit is not equals to the value of the function. Therefore the given function is not continuous. Therefore f is a discontinuous at x is equals to 0. Now third, f of x is equals to 4 raised to x minus 2 raised to x plus 1 upon 1 minus cos of 2x for x is not equals to 0 and equals to log of 2 bracket square upon 2 for x is equals to 0. Now this type of the problems are very nice problems. या प्रकारची प्रश्न परीक्षेत विचारले जाऊ शकतात. f of 0 is equals to log of 2 bracket square upon 2. Now f of 0 log of 2 bracket square upon 2. Therefore limit x tends to 0, f of x, limit x tends to 0. 4 raised to x minus 2 raised to x plus 1 upon 1 minus cos of 2x. Now to solve this limit, here is a 4 raised to x. 4 raised to x means what? 2 raised to 2 bracket raised to x. And 2 raised to x plus 1 can be written as 2 into 2 raised to x. Then you will get the perfect square of the 2 raised to x minus 1 bracket square. Limit x tends to 0. 2 raised to 2 bracket raised to x minus 2 into 2 raised to x plus 1. Now what is here? 1 minus cos of 2x. Therefore, by using the formula, you will get 2 sine square 2x upon 2. 2 sine square 2x upon 2. That 2 get cancelled. That is limit x tends to 0. 2 raised to x bracket square minus 2 into 2 raised to x plus 1 upon 2 sine square x. Now divide the numerator and the denominator by x square. Therefore again you can see this. This is the important step. I am applying the formula, that is a 2 sine square 2x upon 2. This 2 will get cancelled. म्हणजे काय की डिनोमिनेटरला कसली आवश्यकता लागेल? तर x square ची. Therefore we divide the numerator and the denominator by x square. Limit x tends to 0, 2 raised to x bracket square. Now see this here. Denominator ला आणि numerator ला आपण x square ने divide करणार आहोत. Therefore you will get limit x tends to 0, 2 raised to x minus 1 bracket square upon x square, 2 sine square x upon x square, पुन्हा 2 raised to x minus 1. आपण हे डायरेक्ट ब्रॅकेट मध्ये टाकणार. 2 raised to x minus 1 bracket square upon x square is nothing but 2 raised to x minus 1 upon x whole square upon sine square x upon x square. Now the value of the numerator is a log of 2 bracket square upon 2 into 1 square, that is a 2, log of 2 bracket square upon 2. This is number 2. Therefore from 1 and 2, limit x tends to 0, f of x is equals to f of 0. Therefore f is a continuous at x is equals to 0. Value of the function is equals to the limit of the function. That's why. Now next is, which of the following function has a removable discontinuity? If it has a removable discontinuity, redefine the function so that it becomes continuous. म्हणजे काय की यामध्ये आपल्याला डिफाइन करावं लागणार आहे की आपण लिमिट तर चेंज करू शकत नाही. मग काय चेंज करू शकतो? तर व्हॅल्यू ऑफ द फंक्शन त्या पॉइंटला आपण चेंज करू शकतो. म्हणून तो असं म्हणतो की रिडिफाइन. सी दिस. रिडिफाइन म्हणजे काय की जे लिमिट असतं ते डिफाइन करणार त्या पॉइंटला ती व्हॅल्यू आपण डिफाइन करणार. Now see this first problem. F of x is equals to e raised to 5 sin x minus e raised to 2x upon 5 tan x minus 3x for x is not equals to 0 and equals to 3 by 4 for x is equals to 0 at x is equals to 0. म्हणजे काय की इथे व्हॅल्यू ऑफ द फंक्शन किती दिले त्याने आपल्याला 3 by 4 दिलेले. The value of the function. व्हॅल्यू ऑफ द फंक्शन आपल्याला 3 by 4. जर लिमिट आणि व्हॅल्यू दोन्ही जर सेम आले तर गिव्हन फंक्शन इज अ कंटिन्युअस ॲट एक्स इज इक्वल्स टू 0. पण जर समजा लिमिट वेगळं आणि ही व्हॅल्यू वेगळी असेल देन वी विल रिडिफाइन. रिडिफाइन साठी मग काय की जे लिमिट आलं असतं तेच आपण डिफाइन करणार त्या पॉइंटला. नाउ सी दिस हियर. f of 0 is equals to 3 by 4. This is given. Now limit x tends to 0, f of x is equals to limit x tends to 0, e raised to 5 sin x minus e raised to 2x upon 5 tan x minus 3x. Now what's happening here? म्हणजे प्रत्येकदा मॅथमॅटिक्स मध्ये प्रॅक्टिस एवढी जबरदस्त पाहिजे की प्रॉब्लेम कडे बघितल्यानंतर आपल्याला तो कसा सॉल्व्ह केला जाईल. कॅल्क्युलस मध्ये तसंच असतं. डेरिव्हेटिव्ह मध्ये तुम्ही जेव्हा जाणार, इंटिग्रेशन मध्ये जाणार 12th स्टँडर्डला, तर प्रत्येकदा आपण प्रॉब्लेम कडे बघितल्यानंतर काय काय ऍडजस्टमेंट असेल, कोणाला काय आवश्यकता असेल. नाउ इट इज क्लिअर दॅट द न्यूमरेटर अँड डिनोमिनेटर इज डिवायडेड बाय एक्स. देन व्हॉट विल बी नेक्स्ट? तर इथे काय काय करावं लागणार आपल्याला? इथे -1 आणि +1 बॅलन्स करावं लागणार आहे. या दोघातनं मायनस साइन कॉमन काढावं लागणार आहे आणि या प्रकारे तो प्रॉब्लेम सॉल्व्ह केला जाईल. पण यासाठी कसली आवश्यकता असते? तर यासाठी रोज तुम्ही 15 ते 20 एक्झाम्पल जर तुम्ही सॉल्व्ह केले तर तुम्हाला यामध्ये परफेक्शन मिळू शकतं. Now see this, divide n and d by x. Limit x tends to 0, e raised to 5 sin x minus e raised to 2x upon x upon 5 tan x minus 3x upon x. Now this step is important. न्यूमरेटर आणि डिनोमिनेटर आपण कशाने डिवाइड करत आहोत? तर x ने डिवाइड करत आहोत. that is e raised to 5x minus, this is important. Now here what I had done, e raised to 5 sin x minus 1, कारण की e raised to x minus 1 upon x, the value of that limit is 1. मग यासाठी आपल्याला मायनस 1 ची आवश्यकता लागणार आहे, पण मी इथे जास्तीचा मायनस 1 घेतला, त्याला बॅलन्स करण्यासाठी इथे प्लस 1 घेतला. ओके, पण नंतर हाच प्लस 1 यासाठी उपयोगात पडणार आहे, जर आपण इथनं मायनस साइन कॉमन काढलं तर आपल्याला तो स्टँडर्ड रिझल्ट मिळणार आहे, विच इज दॅट e raised to x minus 1 upon x. And in this way, all this is the clearly the adjustment. फक्त ते तुम्हाला ओळखता आलं पाहिजे. आता न्यूमरेटरला डिनोमिनेटरला आपण जेव्हा x ने डिवाइड केलं तर 5 tan of x upon x. Then what will be the value of this limit is 1. X get cancelled. Then 5 into 1 is 5. 5 minus 3. That will be the 2. मग या प्रकारचा तो प्रॉब्लेम सॉल्व्ह होत असतो. याची तुम्हाला भरपूर प्रॅक्टिस करावी लागणार आहे. Then and then you will understand this. See this again. पुन्हा one thing is that e raised to 5 sin x minus 1 upon x. पण e raised to जे काय असतं तेच खाली पाहिजे असतं आपल्याला. पण इथे किती 5 sin x. मग इथे पण 5 sin x पाहिजे. मग तो जास्तीचा घेणार. पुन्हा त्याला परत करण्यासाठी या न्यूमरेटरला आपण 5 sin x ने मल्टिप्लाय करणार. इथे e raised to 2x आहे. मग खाली पण 2x पाहिजे. म्हणजे इथे आपल्याला 2 ऍडजस्ट करावं लागणार आहे. बघा आता. इथे आपण या नेक्स्ट स्टेपला आपण ती ऍडजस्टमेंट केलेली आहे. Limit x tends to 0, e raised to 5 sin x minus 1 upon 5 sin x into 5 sin x upon x minus e raised to 2x minus 1 upon 2x into 2 upon 5 into tan of x upon x minus 3. Now what's happening here? That is the limit x tends to 0. म्हणजे इथे जर आपण बघितलं की काय की e raised to 5 sin x minus 1 upon 5 sin x, म्हणजे हा कुठला रिझल्ट झाला e raised to x minus 1 upon x, त्या टाईपचा झाला. म्हणून याचं लिमिट किती आलं तर 1 आलं. 5 into sin x upon x, sin x upon x याचं लिमिट किती आलं 1 आलं. दॅट इज हा 5 आणि याचं लिमिट किती आलं तर 1 आलं. मायनस e raised to 2x minus 1 upon 2x. That is here we adjust the 2 to the numerator and the denominator. The value of this limit is also 1. 1 into 2. तर यासाठी आपण त्याच्या ब्रॅकेट मध्ये लिहिणार कोणते रिझल्ट्स आपण वापरले ते. That again tan of x upon x. The value of this limit is also 1. That is 5 into 1 minus 3. Now see this here. फक्त एवढं लिहिलं तरी चालेल. As x tends to 0, sin x tends to 0, 2x tends to 0. That is this result we apply here. Now it is here 5 into 1 5, 1 into 2 2 upon 5 minus 3. That is you will get 3 upon 2. Therefore, this is the limit x tends to 0. F of x is equals to 3 upon 2. This is number 2. Therefore, from 1 and 2, limit x tends to 0, f of x is not equals to f of 0. म्हणजे इथे काय तर रिमूवेबल दिस डिसकंटिन्युटी येणार आपल्याला. म्हणजे आपल्याला काय करावं लागणार की त्याने जी व्हॅल्यू दिली होती फंक्शनची ते आपल्याला चेंज करावी लागणार इथे. Therefore, given function is a discontinuous at x is equals to 0. Hence, discontinuity is removable. We redefine. लिमिट तर आपल्याला चेंज करता येत नाही, पण आपण व्हॅल्यू आपण तिथे तशी ती लिहू शकतो. f of x is equals to e raised to 5 sin x minus e raised to 2x upon 5 tan x minus 3 for x is not equals to 0 and is equals to 3 by 2 for x is equals to 0. जे काही लिमिट आलं होतं ते आपण इथे लिहिणार 3 by 2. Next is f of x is equals to log of 1 plus 5x upon to the base 1 plus 3x. Now see this here, log of 1 plus 5x to the base 1 plus 3x. या वर्षी लॉग हे चॅप्टर्स मुळात त्यांनी घेतले नाही आणि त्या टाईपचे एक्झाम्पल्स इथे मात्र दिलेले. फॉर एक्स इज ग्रेटर दॅन 0, फॉर एक्स इज पॉझिटिव्ह and equals to 32 raised to x minus 1 upon 8 raised to x minus 1 for x is negative at x is equals to 0. यामध्ये बघा इथे आपण दोन टाईपचे लिमिट्स घ्यावे लागणार आपल्याला. हे राईट हँड साइड लिमिट येणार बिकॉज एक्स इज पॉझिटिव्ह आणि या ठिकाणी आपल्याला लेफ्ट हँड साइड लिमिट घ्यावं लागणार आहे आणि व्हॅल्यू पण इथेच असणार आहे एफ ऑफ 0. त्यासाठी फर्स्ट ऑफ ऑल विल फाइंड आउट द लिमिट. परंतु ते फाइंड आउट करण्यासाठी आपल्याला इथे लॉगची प्रॉपर्टी ते अप्लाय करावी लागणार आहे. दॅट इज अ लिमिट एक्स टेन्स टू right hand side limit of f of x, limit x tends to 0, log of 1 plus 5x to the base 1 plus 3x. Then we can change this. It is like this, log of 1 plus 5x whole divided by log of 1 plus 3x. By using the rules of logarithm, that is a log of 1 plus 5x upon log of 1 plus 3x. आता लॉग साठी आपल्याला x ची आवश्यकता असणार आहे. Therefore, divide numerator and the denominator by x first of all. कारण की त्याचा स्टँडर्ड रिझल्ट काय आहे की लिमिट x टेन्स टू 0 log of in bracket 1 plus x upon x, the value is 1. आणि म्हणून आपण न्यूमरेटरला आणि डिनोमिनेटरला आपण x ने डिवाइड करणार आहोत. In this way, divide numerator and the denominator by x. नेक्स्ट स्टेपला 5 ऍडजस्ट करणार न्यूमरेटरला आणि डिनोमिनेटरला 3 ऍडजस्ट करणार. log of in bracket 1 plus 5x upon 5x into 5 upon log of 1 plus 3x upon 3x into 3. Therefore, the value of this limit is 1. 1 into 5 is 5. 1 into 3 x नको पाहिजे इथे, तो चुकून x आलेला आहे. I will cut it. Therefore, it's a 5 upon 3 log of bracket 1 plus 5x upon 5x upon log of 1 plus 3x upon 3. And the value of this limit is 1, 1 upon 1. That is 1. And hence the limit is 5 upon 3. Therefore, limit x tends to 0. Right hand side limit is 5 upon 3. This is 1. Next is limit x tends to left hand side limit, and for that we will take the function that is a 32 raised to x minus 1 upon 8 raised to x minus 1. मग इथे देखील तसंच असणार आहे. आपला स्टँडर्ड रिझल्ट काय आहे तर a raised to x minus 1 upon x. Then the value of this limit is log of a. For this reason, we will divide first of all numerator and denominator by x. Divide n and d by x. Therefore, left hand side limit 32 raised to x upon x and 8 raised to x upon x. This is divide n and d by x. Now the value of this limit is log of 32. कुठला फॉर्म्युला आपण इथे अप्लाय करत आहोत. That is limit x tends to 0 a raised to x minus 1 upon x. It's a log of a. तसंच इथे limit x tends to 0 32 raised to x minus 1 upon x is log of 32 and divided by log of 8. Now log of 32 means what? 2 raised to 5 and 8 means what? 2 raised to 3. Therefore, again by using the rules of the logarithm, that is a 5 upon 3 log of 2 upon log of 2. That is this log of 2 get cancelled and you will get 5 upon 3. And therefore limit x left hand side limit is 5 upon 3. This is number 2. And therefore from 1 and 2 right hand side limit and the left hand side limit both are equal. That is the limit x tends to 0, f of x is equals to 5 upon 3. Therefore f of 0 is not defined there. Value was not given. Therefore now we will write their values. F is a discontinuity at x is equal to 0. This discontinuity is removed by redefining. We will redefine that is f of x is equal to log of 1 plus 5x to the base 1 plus 3x for x is greater than 0 and 5 upon 3 for x is equal to 0 and 32 raised to x minus 1 upon 8 raised to x minus 1 for x is less than 0. In this way, we redefine to be the given function continuous. Third is now third problem. F of x is equals to 3 minus 8x upon 3 minus 2x bracket raised to 1 upon x for x is not equals to 0. And in this case, we will apply the formula that is a limit x tends to 0, 1 plus x bracket raised to 1 upon x. The value is e. Therefore, now see this here. 3 minus 8x upon 3 minus 2x bracket raised to 1 upon x. Now in place of the 3 we require here 1. Therefore this numerator and denominator will divide by 3. Now see this again. जर समजा तुम्ही लिमिट चॅप्टर पूर्णपणे सगळे एक्झाम्पल सॉल्व केले असतील तरच हे कंटिन्युटी मात्र समजणार आहे. नाउ डिवाइड that is limit x tends to 0. We divide this numerator and denominator by this numerator and denominator. If we divide by 3, then you will get 1 minus 8 upon 3x 8x upon 3, and to the denominator if we divide 3 minus 2 is divided by 3, then you will get 1 minus 2 upon 3x. Now again see this here. आता adjustment करना, that is a 1 minus 8 upon 3x bracket raised to, now see this here. I will show the both adjustment. Now see this here, 1 minus 8x upon 3. मग याच्या रेस टू काय पाहिजे तर त्याच्या रेसिप्रोकल पाहिजे. Originally we have the term that is the 1 upon x was the term there, and now to balance this, now again see this again. आपल्याकडे फक्त 1 upon x आहे तिथे. Separate it. मग त्याच्या रेस टू किती आला पाहिजे मायनस 3 upon 8x आणि आपल्याकडे 1 upon x होता. आता हा मायनस 3 upon 8 बॅलन्स करण्यासाठी आपण या ब्रॅकेट रेस टू किती करणार मायनस 8 upon 3. म्हणजेच आपलं ओरिजिनल एक्झाम्पल जसं तसं असणार आहे. This is first part. And now value of this limit will be the e raised to minus 8 upon 3. आता डिनोमिनेटरला पण तसंच करावं लागणार आपल्याला. 1 minus 2 upon 3x bracket raised to minus 3 upon 2x. मग इथे देखील आपण कोणते ऍडजस्टमेंट करणार आहोत तर minus 2 upon 3 ऍडजस्ट करणार आहोत. Now the value of this limit is e raised to minus 8 upon 3, and here is a e raised to minus 2 upon 3. Minus 8 upon 3 e raised to minus 2 upon 3. And now we will solve this. As x tends to 0, 8x minus 8 upon x that tends to also 0. Therefore the answer is e raised to minus 8 upon 3 minus in bracket minus 2 upon 3, and therefore you will get minus 8 upon 3 plus 2 upon 3, that is a minus 6 upon 3, that is e raised to minus 2. Sorry, e raised to minus 2. What is the limit? Limit is e raised to minus 2 there. Therefore we define the function that is f of x is equals to 3 minus 8x upon 3 minus 2 is bracket as to 1 upon x for x is not equals to 0 and f of 0 is equals to e raised to minus 2 to the given function is a continuous. Again I will show this. हा redefining पुन्हा important आहे. बिग चॅप्टर आहे. तुम्ही जर समजा 7व्या चॅप्टरचा पूर्णपणे अभ्यास केला असेल तरच हे समजायला सोपं जाईल. कारण की त्याच्या पुढची एक स्टेप घेतली ज्याला लिमिट टोटली फाइंड आउट करता येणार आहे त्याला हे जमणार आहे. दिस इज redefined. Now next is number 4. f of x is equals to 2x plus 3 for x lies between minus 4 and minus 2 and equal to minus 4 and equal to minus 2. And f of x is equals to 2x minus 3 for x lies between 2 and 6 and equals to 6 for this. Now what is here? The function break at these 2 points minus 2. These are the breaking points. या ठिकाणी फंक्शन ब्रेक होतो की -4 टू -2 हा फंक्शन असणार आहे आणि -2 पासून 6 पर्यंत हा फंक्शन असणार आहे. म्हणून मी प्रत्येकदा असं म्हणतो की फंक्शन कुठे ब्रेक होतो तर -2 ला ब्रेक होतो. Therefore we will find out the left hand side limit and the right hand side limit at x is equals to -2. Now see this here. For this we will find limit x tends to -2, that is the left hand side limit. Now त्यासाठी आपण तो पहिला फंक्शन घेणार, substitute x is equals to -2 and what is the left hand side limit is the normal, it is a -4. पुन्हा तुम्ही बघू शकता. This is first one. Now we'll find out the right hand side. मग तो right hand side चा फंक्शन घेणार नंतरचा limit x tends to -2, 2x minus 3. Now substitute x is equals to -2. Then you will get -4 minus 3, that is a -7. This is the right hand side limit. Now what's happening here? That is the left hand side limit is not equals to the right hand side limit. Limitच exist नाही तर continuityचा प्रश्न उद्भवणार नाही. And therefore this is the irremovable discontinuity. The limit of function does not exist and hence this discontinuity is irremovable. ज्या वेळेस लेफ्ट हँड साइड लिमिट आणि राइट हँड साइड लिमिट बोथ आर डिफरंट किंवा लिमिटच एक्झिस्ट होणार नाही त्यावेळेस डिसकंटिन्युटी इज ऑलवेज इरिम्युएबल. आपण रिमूव्ह करू शकत नाही. कमीत कमी त्याला लिमिट हे एक्झिस्ट असलं पाहिजे. देन वी कॅन डिफाइन देअर व्हॅल्यूज. नाउ नेक्स्ट f of x is equals to x raised to 3 minus 8 upon x square minus 4 for x is greater than 2 is equals to 3 for x is equals to 2 and is equals to e raised to what is here e raised to 3 in bracket x minus 2 bracket square minus 1 upon 2 in bracket x minus 2 bracket square for x is less than 2 at x is equals to 2 f of 2 is equals to 3. This is 1. Now we will find the limit x tends to right hand side limit. X cube minus 8 upon x square minus 4. Now their factors x minus 2 x square plus 2x. A cube minus b cube चा फॉर्म्युला इथे अप्लाय करणार. a minus b a square plus ab plus b square. डिनोमिनेटर चा फॉर्म्युला सोपा आहे. a square minus b square, that is a minus b a plus b. X minus 2 get cancel and then substitute the values. you will get 12 upon 4, that is equals to 3. Therefore, the right hand side limit is equals to 3. This is 1. Limit x tends to, that is the left hand side limit, 2 f of x, limit x tends to 2 e raised to 3 in bracket x minus 2 bracket square minus 1 upon. Now what's happening here? म्हणजे e raised to च्या डोक्यावर जे काय आहे तेच इथे खाली दिलेलं आहे. फक्त आपल्याला हे लिमिट सॉल्व्ह करायचं आहे. कुठला स्टँडर्ड रिझल्ट आपण इथे अप्लाय करणार? e raised to x limit x tends to 0 e raised to x minus 1 upon x. हा स्टँडर्ड रिझल्ट आपण इथे अप्लाय करणार आहोत. Now see this here, we will apply here substitution, put x is equals to 2 plus h. या प्रकारचा जेव्हा प्रॉब्लेम येईल प्रत्येकदा मी असं सांगितलंय की x is equals to whatever that tends to, it tends to 2 plus h. As x tends to 2, h tends to 0. These are the fixed dialogues for the method of substitution to solve the limit. Therefore, limit x tends to 2 f of x, h tends to 0 e raised to 3h square minus 1 upon 3h square. मग एक गोष्ट काय राहिली इथे 3h स्क्वेअर पाहिजे आपल्याला. इथे 2h स्क्वेअर आहे. आपल्याला किती ऍडजस्ट करावं लागणार आहे? तर इथे 3 ऍडजस्ट करावे लागणार आहे. That is limit h tends to e raised to 3h square minus 1 upon 3h square into 3 upon 2. Now the value of this limit is 1. 1 into 3 by 2. That is equals to 3 by 2. And what is the value of the function? If the value of the function given is not equals to, left limit is not equals to the right limit. Therefore, limit x tends to 2 f of x does not exist. म्हणून कंटिन्युटीचा प्रश्न नाही. म्हणून प्रत्येकदा असंच काय की whenever the left limit does not exist, then there is no question of the continuity. But when the limit exists, then we redefine the discontinuity will be removable. पण इथे आता लिमिटच एक्झिस्ट नाहीये म्हणून हा कंटिन्युटीचा is irremovable. F is discontinuous at x is equals to 2 and this discontinuity is irremovable. आपण रिमूव्ह करू शकत नाही. Next we'll see. Now we'll see the problem number 10. The first, if f of x is equals to in root of 2 plus sin x minus root 3 upon cos square x for x is not equals to pi by 2 is continuous at x is equals to pi by 2, then find the f of pi by 2. Now limit x tends to pi by 2 f of x is equals to limit x tends to pi by 2 in root of. Now what's happening here? The given function is continuous. The limit of the function is equals to the value of the function. That's why our job is to find out the limit of this function only. Now to solve this limit, we will multiply. This is a irrational number. To the numerator, we multiplied. It's a rationalizing factor. That is limit x tends to pi by 2 root 2 plus sin x minus root 3 into root of 2 plus sin x plus root 3. Now cos square x means what? 1 minus sin square x into root of 2 plus sin x plus root 3. That is limit x tends to pi by 2. Now what is happening here? A minus b into a plus b is a 2 plus sin x minus 3. And to the denominator 1 minus sin x into 1 plus sin x into in root of 2 plus sin x plus root 3. Therefore, limit x tends to pi by 2. That is a sin x minus 1 upon in bracket 1 minus sin x into 1 plus sin x in root of 2 plus sin x plus root 3. Now from the numerator or the denominator we will take the minus sign common. Then these two terms will get cancelled. Now see this here. Limit minus sign is common. From the numerator, limit x tends to pi by 2. 1 minus sin x upon 1 minus sin x into 1 plus sin x in root of 2 plus sin x plus root 2. Now 1 minus sin x get cancelled, and that's why minus limit x tends to pi by 2 1 plus sin x in root of 2 plus sin x plus root 2. Now substitute x is equals to pi by 2, that is minus 1 upon in first bracket 1 plus sin of pi by 2 into in root of 2 plus sin of pi by 2 plus root 2. Now here I am changing the value, that was root 3. Therefore root 3 plus root 3, that is a 2 times root 3. I had changed it. Now you can understand it. That is a minus 1 upon 4 root 3. Therefore f of pi by 2 is equals to the limit of the function, that is equals to minus 1 upon 4 root 3. I will show you it again. This is the value of the function. Now next is number 2. If f of x is equals to cos square x minus sin square x minus 1 upon in root of 3x square plus 1 minus 1 for x is not equals to 0 is a continuous at x is equals to 0, then find f of 0. Now the given function is continuous. We want to find out only the limit of this given function. This is always definition. The limit of function is equals to the value of the function. Therefore f of 0 is equals to limit x tends to 0 of the f of x. That is a cos square x minus sin square x minus 1 in root of 3x square plus 1 minus 1. Now, this limit x tends to 0. What is meant by the cos square x? The cos square x is 1 minus sin square x. Now you will say that why we are not replacing here 1 minus cos square x? Because if you multiply here the rationalizing factor, then plus 1 and minus 1 will get cancelled, then you will get x square and sin square x upon x square, that the value of the limit will be the 1. Now see this here. Now we'll multiply the rationalizing factor, limit x tends to, this is numerator 1 minus sin square x minus sin square x minus 1 plus 1 and minus 1 get cancelled, then you will get minus 2 sin square x. Now multiply it with the minus 2 sin square x in root of 3x square plus 1 rationalizing factor into root of 3x square plus 1. Now this is the multiplication. Now these two terms will get cancelled. That is the limit x tends to 0 minus 2 sin square x, that is 3x square plus 1 minus 1 and plus 1 minus 1 will get cancelled, then you will get 3x square plus 1. Now these two terms will get cancelled. Therefore limit x tends to 0 minus 2 sin square x upon 3x square in root of 3x square plus 1 plus 1. Now the value of that limit, that is a minus, now see this again, minus 2 upon 3 sin square x upon x square in root of 3x square plus 1. As limit x tends to 0, is the value of this limit is 1 square. X is equals to 0, it will become 0. Therefore, you will get minus 3 by 2. Again, you can see this also. Sin square x upon x square, that value will be the 1. And next is, and overall that is equals to minus, this is a 2, 1 plus 1 is 2, 2 into 2, 4, that is a minus 4 upon 3. Therefore f of x, therefore by the definition, f of 0 is equals to limit x tends to 0, f of x, that is a minus 4 upon 3. If f of x is equals to 4 raised to x minus pi plus 4 raised to pi minus x minus 2 upon pi upon x minus pi bracket square for x is not equals to pi is continuous at x is equals to 0. Then find f of 0. The given function is continuous. Then we'll find out the limit of the function. Now it is written as like this. 24 means what? 8 into 3 bracket raised to x minus 8 raised to x minus 3 raised to x plus 1 upon 4 into 3 bracket raised to x minus 4 raised to x minus 3 raised to x plus 1. Now from these two, numerator and denominator, we will take the common. That is the 8 raised to x is common from here and the minus sign is common from here. That is limit x tends to 0. 8 raised to x in bracket 3 raised to x minus 1 minus in bracket 3 raised to x minus 1, and from the denominator we will take 4 raised to x as a common. 3 raised to x minus 1 minus 3 raised to x minus 1, and again. Now divide numerator and the denominator by x because 3 raised to x minus 1 from the numerator and denominator get cancelled. Therefore, limit x tends to 8 raised to x minus 1 upon x. 4 raised to x minus 1, that is the log of 8 upon log of 4. Log of 8 means what? 2 raised to 3. And log of 4 means what? 2 raised to 2. That is equals to 3 upon 2 log of 2 upon log of 2. That is a 3 upon 2. Therefore, f of 0 is 3 upon 2. The value of the function, that is equals to, the limit x tends to 0, f of x is equals to 3 by 2. Second, if f of x is equals to 5 raised to x plus 5 raised to minus x minus 2 upon x square for x is not equals to 0, and that equals to k for x is equals to 0. We have solved this type of the example. That is 5 raised to x plus 5 raised to minus x minus 2. It's a perfect square. That term is a perfect square. By the definition, f of 0 is equals to the limit x tends to 0, f of x. Limit x tends to 0, 5 raised to x minus 2. Now here is the perfect square we will get here. That is limit x tends to 5 raised to x plus 1 upon 5 raised to x minus 2 upon x square. Limit x tends to 0, 5 raised to x bracket square plus 1 minus 2 into 5 raised to x upon x square. 5 raised to x into x square. Limit x tends to 0, 5 raised to x minus 1 bracket square upon 5 raised to x into x square. That is limit x tends to 0, 5 raised to x minus 1 upon x bracket square into 1 upon 5 raised to x. Therefore, log of 5 bracket square as x tends to 0, 5 raised to 0 will be 1. That is 1 upon 1, 5 log of 5 bracket square. Therefore, f of 0 is equals to limit x tends to 0, f of x is equals to k, and the value of k is a log of 5 bracket square. Therefore, k is equals to log of 5 bracket square. That will be the answer. Now I will again show you. Log of 5 bracket square. This is the value of the k. Now next is k is equals to log of 5 bracket square. Third, if f of x is equals to sine of 2x upon 5x minus a for x is positive, is equals to 4 for x is equals to 0, and is equals to x square plus b minus 3 for x is negative, then find the values of a and b. The given function is continuous. We have given the function, so value is also given. Left limit is equals to the right limit is equals to the value of the function. Therefore f of 0 is equals to limit x tends to 0 plus of f of x is equals to limit x tends to left hand side limit of f of x limit x tends to, that is the right hand side limit, is equals to the, first we'll find out the right hand side, sine of 2x upon 5x minus a. Therefore limit x tends to 0, sine of 2x upon, that is we are balancing here, divided by 2 multiplied by 2, that is the 2 upon 5, sine of 2x upon 2x minus a. If you take the limit, then you will get 1 into 2 upon 5 minus a. This is a long exercise, that is the 2 upon 5 minus a. This is the first part. This is the right hand side limit. Now the left hand side limit, f of x is equals to limit x tends to x square plus b minus 3. As x tends to 0, then you will get b minus 3. This is number 2. Therefore left hand side limit is equals to the right hand side limit. Now right here we will find out their values. तो करण्यासाठी स्क्रीन मला वर खाली करावं लागतो. That is equals to 4 is equals to 2 upon 5 minus a is equals to b minus 3. Therefore we will equate first, that is the 4 is equals to 2 upon 5 minus a, and if we simplify, then you will get the value of a is minus 18 upon 5. Now next is value of the b. 4 is equals to b minus 3. जी काही इक्वालिटी दिली होती आपल्याला 3 टर्मशी, त्यातला 4 is equals to b minus 3. Therefore b is equals to 4 plus 3. Therefore b is equals to 7. These are the values of a and b. Now next, fourth one. For what values of a and b is the function f of x is equals to x plus bx plus 18 for x is less than or equal to 2 is equals to x square plus 3a minus b for x lies between 0 and 2, and last is 8x minus 2 for x is greater than 2. Is a continuous for every x. Now we will see. Check the continuity at the point. Now the function breaks at x is equals to 0 and x is equals to 2. Therefore we will find out the left hand side limit and right hand side limit and the value of the function at x is equals to 0. Also left hand side limit, right hand side limit at x is equals to 2, and then we will get their values. This is checking for the 0, the breaking point. That is limit x tends to left hand side limit, right hand side limit as x tends to 0, and the value of the function at x is equals to 0. F of 0, that is equals to ax plus 2b plus 18, and what is the x is replaced by 0, then you will get 0 plus 2b plus 18, that is a 2b plus 18. This is number 1. Next is limit x tends to left hand side limit f of x, ax plus bx plus 18. Then you will get as x tends to 0, then this term will become 0. That is a 2b plus 18. This is the 2b plus 18. Right hand side limit f of x, limit x tends to 0, x square plus 3a minus b. That is you will get 3a minus b. From the 1, 2 and 3, you will get all the 3's left and right hand value of the functions. That is a 2b plus 18 is equals to 3a minus b. That is equals to 0. is equals to 3a minus b minus 2 minus 18. Therefore 3a minus ab is equals to 18. Therefore a minus b is equals to 6. This is the fourth equation. Now next is at x is equals to 2, limit x tends to 2 plus, that is the right hand side limit. Therefore you will get this here. Now for the right hand side limit is equals to the left hand side limit is equals to the f of 2. Therefore f of x is equals to x square plus 3a minus b. F of 2 is equals to 2 square plus 3a minus b. That is f of 2 4 plus 3a minus b. Therefore f of 2 is equals to 4 plus 3a minus b. This is equation number 5. Now next is left hand side limit. F of x is equals to limit x tends to 2. Therefore we will get 4 plus 3a minus b. This is the equation number 6. That is equals to this is equals to 40 right hand side. And therefore 4 plus 3a minus b, 4 plus 3a minus b (3a minus b is equals to 40 minus 4, that is equals to 10. Therefore 3a minus b is equals to 10. Now we'll solve these two simultaneous equation by subtraction. Then you get the value of a is equals to 2. A minus b is equals to, therefore substitute a is equals to 2, then you will get b is equals to minus 4. Therefore a is equals to 2, b is equals to minus 4. Fifth one, for what values of a and b is the function f of x is equals to x square minus 4 upon x minus 2 for x is less than 2, equal to x square minus bx plus 3 for x lies between 2 and 3, and 2x minus a plus b for x is greater than or equal to 3. Now here given function breaks at the point 2 and 3. Now we will check the continuity at x is equals to 2 and x is equals to 3. At x is equals to 2. Now we'll find out left and right limit and the value of the function. This is important. Left limit is equals to the right limit is equals to the value of the function. The given function break at the 2 and 3 means it changes. Now f of x is equals to ax square minus bx plus 3. F of 2 is equals to a into 2 square minus b into 2 plus 3. This is f of 2, equation number 1. And next is limit x tends to right hand side limit ax square minus bx plus 3. that is a into 2 raised to 2 minus b into 2 plus 3, that is a 4a minus 2b plus 3. Limit extends to 2 f of x. Left hand side limit x square minus 4 upon x minus 2. Therefore, substitute, you will get the answer is 4. Limit extends to right hand side limit is equals to left hand side limit is equals to the value of the function. Now we will equate it all this. Therefore, you will get 4a minus 2b is equals to 1. This is equation number 4. Now we will check the continuity at x is equals to 3. In this case, we here also find the left hand side limit, right hand side limit and the value of the function. Now see this here. Left hand side limit is equals to the ax square minus bx plus 3. Substitute x is equals to 3 and 9a minus 3b plus 3. Value of the function. Right hand side limit. What is the function that we will substitute? The example is very big, that's why I want to change the screen continuously. And now solve these two equations, that is equation number 7 and equation number 4. Now multiply this equation number 4 by 2, then bb will get cancelled. Therefore, after subtraction, that is a 2a is equals to, therefore a is equals to 1 upon 2. Then you can see this. Therefore, a is equals to 1 upon 2. Put a is equals to 1 upon 2 in above equation. That is 4a minus 2b is equals to 1. Therefore, 4 into 1 upon 2 minus 2b is equals to 1. That is a 2 minus 2b is equals to 1. Therefore, b is equals to 1 upon 2. The value of b is also 1 upon 2. I have tried to explain more and more, but the problems are very big problems are here. A is equals to 1 upon 2 and b is equals to also 1 upon 2. Now next, problem number 12. Discuss the continuity of f on its domain where f of x is equals to mod of x plus 1 and x lies between minus 3 and plus 2 is equals to mod of x minus 5 for x lies between 2 and 7. The domain of f, now here clearly that this is start from minus 3 to 7. Therefore, the domain of f is minus 3 to 7. Therefore, we will consider the continuity at x is equals to 2 because the given function, it's a break. Now here is f of 2 is equals to mod of 2 plus 1, that is equals to 3. Therefore, f of 2 is equals to 3, that is the value of the function. Now left hand side limit, that will be the mod of x plus 1, that is a 2 plus 1, that is equals to also 3. It's a big problem in writing. Now the right hand side limit, The function is mod of x minus pi. X is replaced by 2 minus pi, that is a 3. And therefore, in this case, the left hand side limit is equal to the right hand side limit is equal to the value of the function. Therefore, the given function is continuous. F is a continuous at x is equals to 2, and hence f is a continuous on its domain minus 3, 7, closed interval minus 3, 7. And problem number 13. Now we'll see the question number 13. Discuss the continuity of f of x at x is equals to pi by 4, where f of x is equals to sin x plus cos x bracket raised to 3 minus 2 root 2 for x is not equals to pi by 4. And for x is equals to pi by 4, the value of the function is equals to 3 upon root 2. Now we'll discuss here, that is, we will find out the limit of given function, and its value must be 3 upon root 2, then the given function will be continuous. Now let us start. F of pi by 4 is equals to 3 upon root 2. This is number 1 always. Now limit x tends to pi by 4. F of x is equals to limit x tends to pi by 4. Sin x plus cos x bracket square minus 2 root 2 upon sin of 2x minus 1. Put sin x plus cos x is equals to t. Now this is the different one problem, because what type of the substitution you will take, that is very important. That is a sin x. We have the problem in the problem. Now see this here, you can the substitutions, that is a sin x plus cos x bracket raised to 3 and sin x sin of 2x minus 1. Here we take the substitution, that is a sin x plus cos x, that is equals to t here. I am repeating again here. All the problems are very tough. You have to do too much more and more study. Then you will understand. Because this topics was last year for the 12th standard. Sin x plus cos x minus. That is, here we take the substitution sin x plus cos x, that is equals to t. And therefore, as x tends to pi by 4, the value of t is equals to sin of pi by 4 plus cos of pi by 4 is equals to t. That is 1 by root 2 plus 1 by root 2, that is equals to 2 upon root 2, that is a t is equals to root 2. And that's why as x tends to pi by 4, t tends to root 2. This is the substitution. Now the value, that is sin x plus cos x bracket square is equals to t square. If you expand this, then you will get sin square x plus cos square x plus 2 sin x into cos x is equals to t square. Sin square x plus cos square x is 1. 2 sin x into cos x is sin of 2x. Therefore, sin of 2x is equals to t square minus 1. Therefore, limit x tends to pi by 4 sin x plus cos x bracket cube minus 2 root 2 sin of 2x minus 1, that is equals to limit x tends to root 2, that is a t raised to that is one thing is remaining. I will change it. This is the t cube minus root 2 bracket cube and t square minus 2. That is, it is written as root 2 bracket square, then you will get 2. Now divide the numerator and the denominator by not x, it is t minus root 2, and we will apply the formula t minus root 2 ने त्याला divide करना numerator ला and denominator ला. Then we will apply the next formula, that is limit x tends to a x raised to n minus a raised to n upon x minus a. The answer is n into a raised to n minus 1. This is the 3 root 2 bracket raised to 3 minus 1 upon 2 into root 2 bracket raised to 2 minus 1. That is equals to, this is the root 2 bracket square upon root 2, 3 by 2. Then you will get 1 root 2 to the, and overall, that is the limit x tends to pi by 4, f of x is equals to 3 upon root 2. Therefore, f of pi by 4 is equals to limit x tends to pi by 4, f of x is equals to 3 upon root 2. Therefore, f is a continuous at x is equals to pi by 4. Now again, you can see this also. Again, simplification. That is, the denominator 2 can be written as root 2 into root 2. Therefore, limit x tends to pi by 4. F of x is equals to 3 upon root 2. And therefore, f of pi by 4 is equals to limit x tends to pi by 4. F of x is equals to 3 upon, is a continuous. Now next is 14. Determine the values of P and Q such that the following function is continuous on the entire real number line. Again, this is very tough problem that you have to decide it. That is, f of x is equals to x plus 1, where x lies between 1 and 3, and f of x is equals to x square plus px plus q, where the mod of x minus 2 is greater than or equal to 1. Now consider this mod quantity first of all. That is, the mod of x minus 2 is greater than or equal to 1. If you withdraw the mod sign, then you will get plus or minus in bracket x minus 2, which is greater than 1. That is, there are the two values. That is, the x minus 2 is greater than or equal to 1, and minus in bracket x minus 2 greater than or equal to 1. And using these two equations, we will solve this. Now see this. If we add the first inequality plus 2 on both sides, then you will get this minus 2 and plus 2 get cancelled. X is greater than or equal to 1 plus 2. That is, x is greater than or equal to 3. And for this, if we simplify this, then you will get minus x plus 2 greater than or equal to 1. Therefore, x is greater than or equal to 3. Minus x is greater than or equal to 1 minus 2. That is, the minus x is greater than minus 1. It is nothing but the x is less than. If you multiply on both sides by the minus 1, then this sign, which is greater than or equal to, changes less than or equal to. Therefore, x is greater than 3 or x is less than or equal to 1. Now, f of x is equals to x square plus px plus q, or x is less than or equal to 1. This is the first. Because we have the two relations, that is, for the function f of x is equals to x square plus px plus q, we have the two relations. For x is less than or equal to, then it is valid. Next is f of x is equals to x plus 1 for x lies between 1 and 3, and the third one, f of x is equals to x square plus px plus q for x is greater than or equal to 3. This is important. And now we will see this here. Now the given function breaks at the 2 points. It's a 1 and at the 3. Therefore, we'll check its continuity at these 2 points. The given function is continuous on the entire number line. That we will check its continuity at 1 and at 3. We'll check its continuity at x is equals to 1 and x is equals to 3. Therefore, f of x is equals to x square plus px plus q. We will find out its value. What's its value? That's value f of 1 is equals to 1 plus p plus q. This is the value. Now it's a right hand side limit. X tends to 1, x plus 1 is equals to 2. And the next is the left hand side limit. Therefore, from 1 and 2. Therefore, because the given function is continuous, it is not necessary to find out again it's the left hand side limit. That is the 1 plus p plus q is equals to 2. Therefore, p plus q is equals to 4. P plus q, that is equals to 1. This is 3. At x is equals to 3. That is the left hand side limit is equals to the x plus 1. That is if we substitute x is equals to 3. That is, again you can see this here. Now next is at 3, that is equals to 4. It's a left hand side limit. F of x is equals to f of 3, and that is equals to 3 square plus p into 3 plus q. That is a 9 plus 3p plus q. Limit extends to, and therefore this is the fourth one. Limit extends to, left hand side limit is equals to right hand side limit is equals to, that is a 4 is equals to 9 plus 3p plus q. Therefore 3p plus q is equals to 4 minus 9. That is 3p plus q is equals to minus 5. This is the fifth one. P plus q is equals to 1. Now solve these two simultaneously. Subtraction, that is equation 5 minus 3. 3p plus q minus 5. And here plus q minus q get cancelled. That is a 2p is equals to minus 6. Therefore p is equals to minus 3. Put p is equals to minus 3. Therefore p plus q is equals to 1. Minus 3 plus q is equals to 1. Therefore q is equals to 1 plus 3, that is equals to 4. P is equals to minus 3 and q is equals to 4. These are the values. Now the question number 15. Show that there is a root for the equation 2x cube minus x minus 16 equals to 0 between 2 and 3. All these are for the different types of the problems here. These are very typical problem that you have to remember. But the solution of this problem is very easy. If we substitute x is equals to 2, then you will get minus sign. If we substitute x is equals to 3, then you will get the positive sign. It means that the root of this function lies between 2 and 3. These are the, again, the 12th standard problems last year. Mean value theorem. f of x is equals to 2x cube minus x minus 16. We will find out the value. What's its value? If we substitute x is equals to 2, then you will get 2 into 2 raised to 3 minus 2 minus 16. That is a 2 into 8 minus 2 minus 16, and after solving you will get that is a minus 2, which is a negative. Now next is f of 3, that is a 2 into 3 raised to 3 minus 3 minus 16, that is equals to 54 minus 19. Therefore you will get 35, which is a positive. And now minus 3, here is a 0. We want to find out the solution, that is a root, means it's a value. It lies between minus 2 and 35. Therefore, and f is a continuous on 2 closed interval 2 and 3. Therefore, the by intermediate value theorem for continuous function, there exists C belongs to 2 and 3 such that f of C is equals to 0. This statement we have to write. There exists a C belongs to the closed interval 2 and 3 such that f of C is equals to 0. This is the mean value theorem. The roots of 2x cube minus x minus 16 is equals to 0 lies between 2 and 3. Now the same problem is repeated here. Show that there is a root for x cube minus 3x is equals to 0 between 1 and 2. Again we will here find the value of function at 1, x is equals to 1, which is negative. For x is equals to 2, then it will be the positive. Therefore root lies between 1 and 2. And again the same dialogue is there, minus 2, 0 and the 2. Therefore f of 1, 0 and f of 2. F is a continuous on closed interval. Therefore by the intermediate value theorem for continuous function, there exists C belongs to closed interval 1, 2 such that f of C is equals to 0. The roots of x cube minus x is equals to 0 lies between 1 and 2. Now the question number 17. This is the activity. Let f of x is equals to x plus b, where a and b are the unknown. X square plus 5 for x belongs to set of the real number. Find the values of a and b so that f of x is a continuous at x is equals to 1. That is, now see this here. They have given the graph. These are the points. F of x is equals to x square plus 5. We want to find out that unknowns. F of x is equals to ax plus b. Now what is the value of x square plus 5? And what is the value of f of 1? Substitute x is equals to 1 in both the equation. Then you will get a plus b is equals to 6. This is the only the x is equals to 1. F of x is equals to x square plus 5. That is, limit x tends to 1, f of x, limit x tends to 1, ax plus b. Therefore a plus b as given function is continuous. Its value and the limit both are equal. Therefore a plus b is equals to 6. आणि शेवटचा प्रॉब्लेम देखील याच प्रकारे त्याने घेतलेला आहे. दॅट इज ऍक्टिव्हिटी. सपोज दॅट f of x is equals to px plus 3 for x lies between a and b, and f of x is equals to 5x square minus q, and where x lies between b and c. Find the condition on P and Q so that f of x is a continuous on P and Q so that the f of x is a continuous on A and C by filling in the boxes. F of x is equals to the given function px plus q, that is f of b is equals to, substitute the value, that is a pb plus 3. Next is pb plus 3 is equals to 5b square minus q, and find out the value of the p. या प्रकारचा लास्ट प्रॉब्लेम त्याने घेतलेला आहे. भरपूर कॉम्प्लिकेटेड आणि क्लिष्टता त्यात यामध्ये घेतलेली आहे, परंतु हे प्रकरण लर्न करण्याच्या आधी, शिकण्याच्या आधी तुम्ही आधी कंटिन्युटी चॅप्टर नंबर 7 आधी क्लिअर करा. देन फॉलो द चॅप्टर नंबर 8 till too much complications are there, but one thing is that only do the study of those problems, that is show that the given function is a continuous, find the value of the constant. This type of the problems are important in this exercise. Now we'll see in the next video. Till then, goodbye.